All right, let's get into it. The big engineering showdown, von Mises versus Tresca. So here's the thing. Real-world stress isn't just one number. It's pulling and pushing everywhere. You can't just compare this complex mess to a simple strength test. We need a smarter way. And that's where failure theories come in. They boil all that chaos down to one single useful number. First up, we've got the modern champ, von Mises. It's the default in most software you'll see today. The whole idea behind it is distortion energy. That's the energy that actually changes a material's shape. So it separates the energy that just squishes apart from the energy that actually warps it. And this is key, because only that shape-changing energy is what makes ductile metals permanently yield. Okay, now for the other contender, the older, simpler one, Tresca. Tresca's theory is way simpler. It just says failure happens when the biggest shear stress hits a critical point. So how do these two actually compare? Let's put them head to head. You can see the whole difference in this one chart. See how the Tresca hexagon fits inside the ellipse? Since it's on the inside, Tresca will always predict failure at a lower stress. It's more cautious. This means Tresca is more conservative, with a larger safety margin. Von Mises allows for leaner designs.
So how big of a difference are we talking? At its maximum, it's about 15.5%.
Okay, so the big question, which one should you actually use? Let's get into it. For most ductile metals, like steel, von Mises is your go-to. It just matches the data better. But, and this is a really big but, there's a critical warning here. Do not use either of these for brittle materials. They don't yield, they just snap. Totally different failure. And remember, this is all about a single, static failure, not fatigue life over many cycles. So, which gives you more confidence? The more accurate von Mises or the safer, more conservative Tresca?